Hello everyone and welcome to Module 3 of the Ester Advanced course. Today we will work with the Google Colab notebook in order to build a completely end-to-end record linkage pipeline using machine learning tools. So again, let's go back to our favorite slide. This is the record linkage pipeline as you know it. We start by data collection, cleaning and normalization, blocking, field comparisons, and finally scoring and evaluation. We will do all of these steps together within one script today. Very good. Remember that to start a Google Colab notebook, you need to be inside the Google Drive. Here, as you know, I have this Ester folder where I'm keeping some of the exercises that we are doing these days inside my Google Drive. So let's start by creating a new notebook, collaboratory notebook, that we can name Module 3 Record Linkage Advanced Course. Very good. So the first thing that we are going to do, as we did before, is to install the helper functions from the GitHub repository that we are providing for you, and mounting Google Drive on top of this notebook. So this can be done, remember, with this command that helps you install packages in Python. We are installing the Ester linkage package, and then we are mounting the Google Drive with this command. Okay? And we are ready to go. So the first thing that we will do here is, as we did the last time, read the data from our source, target, and truth file. Remember, those files can be found in this case in the example of Module 3 here in my Google Drive. Okay? You can also browse those files by looking here, Drive, My Drive, Ester, Module 3. Okay? So this is exactly the path I'm putting here, and then I'm simply loading as pandas data frames these three files: the source file, the target file, and the truth file. Of the truth file, I'm only keeping, in this case, 50 instances, because I want to simulate a scenario where most of the data is not labeled. We only have a minority of the data that has been labeled manually by clerical review. Okay. So we load this data, and the first thing we want to do is to inspect how the data looks like. Let's have a look at the source file. The source file looks like this. We have a first name, we have a surname, gender, birth date, and then some variables that we are not going to use, and an identifier that is mostly empty most of the times. We can also inspect the target file. In this case, the identifier we have it more times: first name, last name, sex, and birth date, and visit date as well. Okay. So as you can see, the size of those files is relatively big already. 500 rows for the source file, 20,000 rows for the target file. Let's inspect the gold standard, just for completeness. Gold standard contains the source index and the target index, and is not very big. It actually contains only 50 columns. Okay, you can check the shape of any data frame like this: 50 rows and 2 columns. Okay, very good. So now we will start our record linkage, building the blocks of our record linkage pipeline. And for this, the only Python concept that we need to learn is the concept of functions. So functions can be defined in Python with this syntax. So for instance, we can do a function that is called squared, that gets x as an argument and returns x to the square, okay, or x times x. So if we define this function, Now we can call it anywhere downstream the code. This should give 4, right? This should give 9. Very good. So we will work with this concept of functions throughout the code now, so that we will assign to each of the record linkage pipeline steps one function. Okay, so let's just start by defining the function of the matching step, which is the first one. In this case, the first thing we want to do, as we did previously, is define a mapping between the column names of the target file and the column names of the source file. And this mapping, I think, corresponds to this one that I have put here. Identifier in the source file corresponds to identifier in the target file. First name to first name with a dash, gender to sex, birth date without a dash to birth date with a dash, date to visit date, etc. Okay, this is what we are defining here. We are defining the matching. Now we can write a function that takes as input a data frame and columns. Actually, the columns that we have just defined. And this matching is going to import from our module, as we did in the previous session. It's going to import this class that is going to help us doing the matching. So match will basically get calls and then match the data frame. Yeah, and we will return this. So what happens here is that if we now run match on the source file, match is the function that we've just defined, we have renamed the columns of this file to something that corresponds to the target file. Okay, and this is very convenient downstream for working downstream and basically homogenizing our data sets. Okay, very good. So we have a function for the first step. Let's go to the pre-processing step, which is the second step of record linkage pipeline. In this case, in pre-processing, basically what we want to do is to clean our data a little bit. So you might see here that our data, especially the names, do not have the same degree of capitalization than the target data. Okay, this is fully capitalized, and this only has capital letters. Only the first character is in capital. So we want to homogenize this, and perhaps what we want to do is to convert everything to lowercase. Same with the sex variable, right? It's in capital letters here and is in lowercase here. So we want to convert everything to an homogeneous format, and for this we can define a function that is going to be called preprocess, that is going to do exactly this. So the way this function is going to work is we first instantiate this clean class that I have provided in the GitHub repository. You can check it if you are curious about it. And then for each column, in all the columns that I find in my data set of input, basically I just check if the column is either birth date or visit date, then I want to treat this column as a date. Yeah, and so I clean it as a date. Else, it means that the column can be treated as a string, I clean it as a string, meaning I convert it to lowercase. Okay? We have cleaned the data correspondingly, so that is homogenized between the source file and the target file. So this function is defined now. Very good. Let's see what it does. If I run it on the source file, it's converting everything to lowercase. If I run it on the target file, it's also converting everything to lowercase. And you might notice here that it has changed the format of the dates. Okay? So now we have something that looks much more homogeneous in terms of format between the source file and the target file. The next step of the record linkage pipeline is blocking. So remember that for blocking, we also provide a helper function. In this case, can be found under the block class. So we can define here within the notebook a function that is going to do the blocking for us. What do we want as arguments for this function? We want a data frame A, a data frame B, that's the source file and the target file, and the columns that we're going to use for blocking. In our case, remember that our favorite columns were first name and last name. I think that this is enough for blocking. Okay? K equals 5. So you can see here that this function contains some default parameters. Yeah, unless we say it otherwise, it's going to use these two variables for blocking, and it's going to assume a K of 5. We can of course set other parameters if we want to use this function with other configurations, okay? But if nothing is specified, it's going to use this by default. Right, so what's going to happen here inside the function is the following. We are going to block data frame B, that is the target file, using these columns and with a K of 5. And we will query the source file using the exact same column, the first name and the last name. Yeah? So we can define this function. Okay, so let's run the pipeline so far so that we make sure that everything is working. Remember, we have matched the source file with this function. Then we are cleaning this source file. We are also cleaning the target file. And now we are blocking. Remember that the outcome of the blocking step is a selection of pairs that we want to consider downstream. No need for specifying the columns and the K because we set some defaults that we already like. Very good, so we have obtained already some pairs. Let's have a look. We have for each row in the source file 5 candidates. Okay, because we specified a K of 5. So far so good. So the next step of the record linkage pipeline, if you remember, are the comparisons. So in this case, I want to do the same comparisons that we were doing in the previous course, and I also want to do within the same function the splitting. If you remember, that essentially prepares all the data for to make it amenable for machine learning downstream. Yeah, so I'm importing the compare and the split helper functions that we've prepared for you, and we will define a compare function like this that takes as inputs the pairs that we have, that we want to consider, a data frame A, the source file, a data frame B, the target file, and the gold standard, the FG. Okay. Remember how this compare class worked? We first instantiate it, and then we specify the type of comparisons that we want to do. We want to compare the identifier in an exact fashion, and then we want to compare the first name with two string metrics, Jaro, Winkler, and Levinstein. Also the last name with two string metrics, Jaro, Winkler, and Levinstein. Then the sex, we want to match it exactly, give it a high score if it matches exactly. We want to measure the difference in birth dates, and we want to measure the difference in visit dates, right? The time difference between the birth dates and the time difference between the visit dates. We compute all of these similarities and store it in a features vector. Yeah, and then we split our data. Okay, then we split our data. I want to keep half of the data in the training set, half of the data in the test set. And what I'm returning here in this function is actually the result of this splitting. So let me keep the function, and let's see how it works. Okay, we pass as arguments the pairs, the source data set, the target data set, and the gold standard data set. This seems to run fastly and nicely. So as we did in the previous notebook, let's inspect how this splits dictionary looks like. It contains the pairs, it contains the Y, ones and zeros, match, not match. The X, this corresponds to the 8 comparisons that we are doing. The train indices, the indices that we are going to use for the training, the indices that we are going to use for the validation, and the rest of the indices. Okay? Very good. So now the only step that is missing is the scoring. And for this, we will import, remember scoring when we are doing a supervised machine learning essentially means classification in this case. So for this we are going to import modules from sklearn. In the previous notebook we used a random forest classifier, another famous classification algorithm that is very simple to understand and very simple to use and works nicely in many scenarios is the logistic regression classifier. Okay, we can import this classifier like this from sklearn, and we are also importing precision recall and F1 score metrics. So now we are going to define from here a function that is going to call score and validate, that will take as input our splits dictionary, okay, where all of the data is residing. Okay, so the first thing we are going to do is instantiate our classifier. You can do it like this, and then to simplify a little bit the syntax, we are gonna enumerate the elements that we find inside the splits dictionary. So the X is assigned to a variable called X, the Y is assigned to a variable called Y, train indices, validation indices, and then we use this to filter our X and our Y for the train set and the validation set, okay, as we did previously. Now we are ready to fit with the training set, and we are ready to predict on our validation. So we can already see, and perhaps we want to print the performance of this classifier, which hopefully is going to be good. to remember, we can do it like this: precision score of our truth in the validation set and our predictions in the validation set. Okay? Recall score the same and F1 score the same. What do we want to return? Nonetheless, in this function, it's actually the prediction for the full data set, right? Because we want to link all the data. And for this, we simply pass x as an argument for the predict function. Okay? So I think that we can already define this function and see if it works. This function is going to give us a prediction. Splits. Okay. And has an argument as argument the splits that we have just obtained in the previous step. Okay, this seemed to work. Let's explore this ypred. Should be a vectors of zeros and ones. Indeed it is. It's a vector of zeros and ones corresponding to our predicted matches 1 or non-matches 0. Okay, so the only thing that's missing now is trying to assemble all of the results so that it becomes more readable and easier to distribute with our collaborators. So for this, we are going to define another function that is going to be called assemble. We have prepared here again a helper class in the GitHub repository for doing that. So the class can be used like this. We first define the function that takes pairs as input, y as our predictions, dfa, that's the source file, and dfb, that's the target file. We instantiate the class like this. Okay, this is how the syntax that works for this particular class that we have defined for this course. And then basically we just want to return whatever we have put here in this assemble class as a data frame. Okay, we have defined a method inside this class that is called as data frame that returns all of the data that we are putting as input as one single data frame. Very good, let's define this function. Okay, let's use this function. We can obtain the pairs from the splits. If you remember, ypred, we have already calculated it here. dfa should be our source file, dfb should be our target file. If we run this, we obtain a big data set, an assembled data set that joins together the source file and the target file. Yeah, so here we have the indices that we have matched, and here we have the columns of the source file to here, and here the columns in the target file. Okay, so now let's check manually that this looks good. For instance, the first match that we found is the first row in the source file and in the row number 463 in the target file. This corresponds in the source file to Ali Membo, who was born in 1969, and in the target file we find Ali Mumba, who was born in the same day. So despite there might be changes here in the letters, perhaps typos or misspellings, this is likely a true positive. Okay, you can check other examples and you can see that the algorithm, despite data being quite noisy in terms of typos, you can see that the algorithm is doing pretty well in finding those matches, those fuzzy matches. Okay, so this is all in terms of all the steps. We have defined one function for each of the steps. Yeah, we have defined one function for each of the steps. So all what remains now is to define to define a wrapper function that is going to run all of the steps together. And this can be done like this. For instance, let's define a function that is called end-to-end pipeline, df source, df target, df gold. Those are the inputs that we want. Yeah, and then we can make this function run all of the steps that we have just manually defined. Yeah, first of all the matching step, then the preprocessing for the source, preprocessing for the target, the blocking, the comparisons, the scoring and validation, and finally the assembly. So the outcome of this function it's the assembled dataset that we have just shown. The input of this function are the original files that we have read. Yeah, so let's try and define this function and see if we obtain exactly the same result. Indeed we do. Okay, so now we have come up with one single method that is going to be able to perform all the steps of record linkage in one line of code. Okay, this is all I wanted to show to you today. Just a final comment on this: if you go to our GitHub repository for the Ester linkage, all of this code can be found here as well. So we have kept all of these functions in a file so that we can in the next session we can directly import this function without having to redefine all the functions together. Okay, I think this is all I wanted to show to you today. See you in the next session.